topic, which is the second part, which is the fluids in motion or in physics. Uh, we call this as the hydrodynamics. So these are fluids in motion. So the objectives for this topic is to differentiate the types of fluid flows, compute and describe the volume and mass flow rates using the continuity equation, and predict fluid speed, pressure, and its effect using the Bernoulli's equation. So the Bernoulli's equation, we won't really deepen our topic on Bernoulli's equation. We just so medyo daanan lang natin yung Bernoulli's equation. We'll discuss the concepts of Bernoulli's equation, how to predict the speed and the pressure of the fluid. Okay. So fluids mechanics are fluids in motion. So as I have mentioned, so this we call this as hydrodynamics. So fluids in motion, these are fluids that is moving. For example, just like the smoke on the incense, um, the fluids in the car. So the gas, oil, water, and the smoke that's coming out from the car. So these are fluids in motion. So these are some example of fluids in motion. So let's go with the types of flow. So what are the types of fluid flows? So we have two types, the streamline and the turbulent flow. So when we say streamline flow, okay, streamline flow, this is it is a type of fluid flow which is smoothly flowing. So the fluid is smoothly flowing. So smooth yung kanyang pag-flow. And when we say turbulent fluid flow, so this is kabaliktaran ng streamline. So if streamline is smoothly flowing, then the turbulent type of fluid flow, so it is medyo messy and it is hindi siya smooth. So that is turbulent and the streamline. First, so that's the ideal fluid. So how can we determine or what are the characteristics of an ideal fluid? So we have here some characteristics which requires to be able for us to say that a fluid is an ideal fluid. If all of these characteristics can be found on a fluid, then we can say that this is an ideal fluid. So first characteristic of an ideal fluid, we have the fluid must be non-viscous. So non-viscous, word non and viscous. So non means no, and viscous is taken from the word viscosity. So it is no viscosity. So an ideal fluid is no viscosity. So we say no viscosity, so therefore the viscosity of a fluid must be equal to zero. Okay? So the viscosity of a fluid must be equal to zero or it has no viscosity. So why is it that we need that an ideal fluid should be no viscosity or non-viscous? Is because um, viscosity, okay, the viscosity of a fluid may affect or it can cause an internal friction. So that's why the fluid should be non-viscous to be an ideal fluid so that there is no internal friction. Okay, there is no internal friction between the layers of fluid because in fluid there are some layers. So if there is a viscosity, okay, if there is a viscosity on the fluid, then there is an internal friction between those layers. So that's why to be an ideal fluid, the fluid must be non-viscous or zero viscosity, so that there is no internal friction between the layers of fluid. Okay, so that's the first characteristic of an ideal fluid. The second characteristic is that um, fluid is incompressible. So when we say that fluid is incompressible, should be that the density, okay, the density of the fluid must be um, remain, or it must the density must remain equal throughout the fluid. So dapat yung kanyang density is equal throughout the fluid, because there are some instances that the density may change if another fluid is mixed. Okay, if there are another fluid that is mixed to the fluid, so therefore its density may change. So to be an ideal fluid, it must be incompressible, or the density remains the same throughout the fluid. So that is the second characteristic of an ideal fluid. So, okay, first we have the fluid is non-viscous. Then second, it is incompressible. The third characteristic is the fluid's motion is steady. Okay, the fluid's motion is steady. So dapat yung kanyang velocity and yung kanyang pressure is the same. Okay? So dapat yung kanyang velocity and pressure is the same even time passes by. So kahit na ilang oras, ilang araw, or buwan, or taon ang buwan, so it should be that the velocity and the pressure of that fluid must remain on its current velocity and pressure. So dapat steady yung kanyang motion. So fluid velocity and pressure at each point in the fluid do not change with time, so it doesn't change. Okay? So that is the third characteristic. So the fourth characteristic, okay, the fourth characteristics of a fluid, of an ideal fluid, is that the fluid has no turbulence. So it moves without turbulence. So as I have mentioned kanina, turbulent type of flow is the is the deep is the um, kabaliktaran um, ng streamline flow. So when we say turbulent type of flow, so therefore the fluid is um, not really smoothly flowing. So hindi siya masyadong smooth yung pag-flow ng fluid. So that is the fourth characteristic. So fluid particles follow a smooth, predictable flow line. So dapat smooth and predictable flow lines because it has no turbulence. So these are the characteristics of an ideal fluid. So if all of these characteristics, okay, so if all of these four characteristics can be found in a fluid, then we can say that that fluid is an ideal fluid. So first, we need to um, that the fluid should be non-viscous, then it is incompressible, and its motion is steady, and thus is its movement. It moves without turbulence. So with these characteristics, we can say that a fluid is an ideal fluid. And so dapat makita rin natin itong apat na characteristics, because if one or more is missing, then that fluid is not an ideal fluid. Okay? If one or more characteristics is missing, then that is not an ideal fluid. Then that is ano ba ang tawag ng ganung mga klaseng fluid? So that is a a real fluid. But every fluids or every existing fluids are real fluids. Okay? So every existing fluids are real fluids. So paano na lang yung ideal fluid if every existing fluids are real fluids? Okay. So um, an ideal fluid, okay? So since it is the ideal fluid of scientists, so this is kumbaga it is a dream fluid of scientists. So ito yung dream nila na makita sa isang fluid that it should be non-viscous, it should be incompressible, it should be it moves without turbulence and its motion is steady. So kumbaga ito ang kanilang dream. So since it is a dream, okay, so since it is a dream, then therefore an ideal fluid doesn't really exist. Okay? So an ideal fluid doesn't really exist. So wala talagang nag-exist na ideal fluid. So since it is only the ideal, okay, it is an ideal or a dream of scientists to to see. So it doesn't really exist because every fluids are real fluids. Because on the first characteristic pa lang, dun pa lang medyo may uh, aberya na. It is because every fluid or every existing fluid has a viscosity rate. So it has a viscosity. So it is not really exact zero. Okay, it is not really exact zero. Though there are some fluids which has a very minimum viscosity. So a very little viscosity. So masyadong mababa yung kanyang viscosity. But viscosity is present on that fluid. So kahit pa gaano kaliit ng kanyang viscosity, but viscosity is still present. So therefore, on the first characteristics, so there is a problem. Okay, so there is a problem. So every existing fluid has a problem on the first characteristic because, as I have mentioned kanina, it should be non-viscous. So it should be no viscosity. But every fluid has a viscosity. Though some of fluids are very little viscosity, so masyadong maliit yung kanyang viscosity, but still it has a viscosity. So that's why, as I have said, an ideal fluid doesn't really exist. So saan ba natin ginagamit itong ideal fluid? So we use an ideal fluid to simplify problems. Okay? To simplify problems, we use an ideal fluid. We okay, we assume that a fluid is an ideal fluid to simplify problems. Okay? To simplify problems. We assume that a fluid is an ideal fluid. But in reality, every fluids are real fluids. And an ideal fluid doesn't really exist. Okay? So that is the, the difference. Okay? So that is the ideal and the real fluids. So and also um, that is the difference between the streamline type of flow and a turbulent type of flow. So I repeat, when we say streamline type of flow, so this is a type of flow which is a smoothly flowing fluid, and turbulent type of flow. So this is medyo messy or um, it is not really smooth. Okay? So it is not really smooth flowing. So hindi siya smooth ang kanyang pag-flow. So that is the streamline and turbulent type of flow. Okay, so the next is we'll discuss or we'll talk about the equation of continuity. So the equation of continuity, the concepts behind equation of continuity is that there is a in if there is a change, so if there is a change in the area of the fluid, okay, so if there is a change in the area of the fluid, then there is also a change in the velocity of the fluid. Okay, so if there is a change in the area of the fluid, then there is also a change in the velocity of the fluid. Okay, so that is the concept of equation of continuity. So just like this illustration, okay, the width of the stream narrows as the water falls and speeds up in accord with the continuity equation. So if you see water flowing from a faucet, we can you can observe that as the water, okay, so as the water flows out from the faucet, yung kanyang area or yung kanyang yung laki ng kanyang um, ng ng water or ng fluid, okay, yung laki niya ay dahan-dahang liliit. So just like this illustration, so as the water flows out from the faucet, so ito yung faucet. So since the water is a fluid, so it will take the shape of the container, and this time the container is the faucet. So since ito yung dinaanan ng tubig, then the container is the faucet, and the area or the yung laki ng ng fluid is the same kung ano yung laki ng faucet. So as you can see, so ito yung faucet. So makikita natin sa illustration na ito rin kalaki yung kanyang um, width or yung kanyang area. So yung area ng tubig, so ito yung kanyang area as it flows out from the faucet, but as the water flows out from the faucet, then because of gravity that is pulling the water to the surface, so because of the gravity that is pulling the water to the surface, then the speed of the water will rise. So tataas yung kanyang speed dahil pinupull siya ng gravity. So because of gravity that is pulling the water, so the speed, okay, the speed of the water, okay, it speeds up. So tataas yung kanyang speed. So at dahil tumaas yung kanyang speed, so makikita natin dito, dahil tumaas yung kanyang speed, unti-unti ring liliit ang kanyang area. So kung makikita natin dito sa may baba, so yung area ng tubig, okay, ito, so yung area ng tubig ay mas maliit if we compared it to the area of the water as it flows out from the faucet. So there is a big difference between the area of the faucet and the area of the water as it is being pulled by the gravity. So in short, we can say that in equation of continuity, we can see that the area, okay, the area. So if there is if the speed, okay, if the speed of um the speed of the fluid increases, if tataas yung kanyang speed, then the area, yung area ng fluid will decrease or liliit yung kanyang area. It is also the same if yung area niya ay tataas, okay? Kung lalaki yung area ng fluid, then yung speed ng fluid is liliit, okay? So liliit rin yung kanyang speed. And also, if liliit yung kanyang area, so if liliit yung kanyang area, then yung speed ng fluid will increase or tataas yung kanyang speed. So because the area, according to the equation of continuity, the area of the fluid is inversely related with the uh, velocity of the fluid. Okay, so according to the equation of continuity, the area of the fluid is inversely related with the velocity of the fluid. So kung tataas yung kanyang area, then bababa yung kanyang velocity. Pero kung bababa yung kanyang area, then tataas yung kanyang velocity. So what is the equation of continuity? Ano ba yung equation na pwedeng magamit natin to predict, okay, to predict what could be the possible value of its velocity if there is a change in area of the fluid, or pwede rin na what could be the possible um, what could be the possible area of the fluid if there is a change in velocity of the on the fluid. So to do that, we'll use the equation of continuity. But what is this equation? So we will um, derive the equation. So if this is a pipe. So you can see there are 2 points on the pipe. So we have point one. So we have point one and point two. Okay. As you can observe, the area on point one is much lesser, or it is much smaller than the area on point two. So mas maliit yung area ng point one kasi mas maliit rin yung kanyang diameter if we compare this to our point two na mas malaki ang kanyang diameter. So the velocity, we have here the velocity on the area 1 and the velocity on area 2, and delta x sub 1 is the change in distance that is traveled by the fluid. So delta x sub 1 is the change in distance that is traveled by the fluid. So to do that, first is if we need the equation for the distance, which is the velocity times the change in time. Okay, so this is, if you can still remember the equation for distance, which is a velocity times the change in time, and the volume, which is area, okay, the area times the change in distance. So the area times the change in distance so that we can solve for the volume. So to be able to solve for the volume, so since hindi natin alam yung kanyang change in time, so we will substitute change in time into the equation of volume. So from A sub 1 to delta x sub 1, magiging A sub 1 to B sub 1 times the delta P. So this will be now the equation for volume. So we have A sub 1, or area, times velocity times the change in time. And we also have the equation of our density, which is m sub 1 over volume. So we will kunin natin yung m sub 1. So magiging m sub 1 is equal to the density times volume. So it is the same. So since we have the equation of volume, which is a sub 1 times b sub 1 times delta t. So gagamitin natin ito as a substitute for our p sub 1 times volume. Okay? So m sub 1, so that is the m sub 1 on point 1 and on point 2. So since they are the same, and since m sub 1 is equal to the m sub 2, so pwede natin, we can substitute the value of our m sub 1 and m sub 2 since they are equal. Okay? So since in this container, okay, since in this container we are using a single fluid, so isa lang yung fluid na ginagamit natin. So therefore, the density of fluid is the same even in point 1 and point 2. So the same lang yung kanilang density. Same with also as its time. So since the same lang yung time interval nila. So, equal lang din kanilang time. So, pwede natin silang i-crush out. So, pwede natin silang ialis since they are equal. So, P sub 1 and P sub 2 are equal and delta T and delta T are equal. So, pwede natin silang alisin to simplify our equation. So, after we crush out, ang naiwan na lang is A sub 1 times V sub 1 is equal to A sub 2 times V sub 2. And that is the equation we will use in the equation of continuity. So A sub 1, which is the area, times V sub 1, which is the velocity, is equal to the area. Okay, so if there is a change in area times the change in velocity. Okay, so this will be the equation we will use in equation of continuity. And this is the equation of continuity. Okay, so let's try to use this equation in a given problem. So the heart pumps blood into the aorta, which is an inner radius of 0.9 centimeter. The aorta feeds 32 major arteries. If the blood in the aorta travels at a speed of 28 centimeter per second, at approximately what average speed does it travel in the arteries if the inner radius of each artery is 0.21 centimeter? Okay, so yung blood daw, it travels into the aorta, which is an inner radius of 0.9 centimeter. And then yung kanyang speed is 28 centimeter per second as it is traveling in the aorta. So ano daw yung kanyang magiging possible speed if nag-change yung area, if nag-change yung radius, okay, if nag-change yung radius ng vessels ng ano to, ng ugat ng tao. So from aorta, then it travels into the artery. So if yung artery is um, mas maliit compared to the aorta, so the area, okay, yung area ng blood, which is the fluid, so yung area ng fluid, which is the blood, reduces from 0.9 up into 0.21 centimeter. So ano daw yung kanyang magiging speed ngayon if nag-decrease ang kanyang area. So using the equation of continuity, just A sub 1 times V sub 1 is equal to A sub 2 times V sub 2. Okay? So first, since area yung kailangan natin, so solve muna natin yung area gamit ang radius. So using the equation for the area of circle, which is pi r square, we'll solve for the area of our fluid. So 0.9 square times pi, that is equal to 0.81 pi square centimeters. That is for the aorta. For the artery, 0.21 square times pi, that is equal to 0.441 pi square centimeters. So since we now have the value of our area, pwede na natin siyang i-substitute sa ating equation of continuity as well as the velocity, which is 28 centimeters per second. So area 1 is the area of aorta, V1 is the velocity of on the aorta, and area 2 is the area on the artery, and V sub 2 is this velocity on the artery. Okay, so solve for V sub 2. So divide both sides by 0.441. So cancel yung pi as well as yung centimeter. So 0.81 times 28 divided by 0.441, that is 51.42 57142857143 centimeters per second. And since the least number of significant figure is only 1, so since 1 lang yung kanyang least number of significant figure, so i-round natin siya into 1 significant figure, and that is equal to 50 centimeters per second. Okay, that is equal to 50 centimeters per second. Okay, for second problem, to calculate the velocity of calculate the velocity. Okay, so calculate the velocity if 10 meters per hour of water flows through a 100 millimeter inside diameter pipe. So what if the pipe is reduced to 50 millimeter inside diameter? Okay, so this time, yung given natin is um, a 100 millimeter diameter of a pipe which flowing with a speed or a velocity of 10 meters per hour. And then, yung pipe daw, nag-reduce siya to a 50 millimeter diameter. So take note, diameter is different from radius because radius is one half of the diameter. Okay? So radius is one half of the diameter. So, and also, yung yung given or yung unit ng ating given, they have different unit. So the speed is in meters per hour and our diameter is in millimeters. So if they have different unit, okay, if they have different unit, so we will convert them first into meters. Convert natin sila lahat into meters. But okay, but if they have the same unit, just like our last example, if they have the same unit, so hindi na natin kailangan na i-convert pa sila. But if they have different unit, okay, just like these examples, so yung kanyang diameter has the same unit, but it is different from the unit of our velocity. So if they have different unit, so convert natin sila lahat into meters, okay? Convert natin sila lahat into meters. But if they have the same unit, the area and the velocity, both of the area and both of the velocity, so if magkapareho lang yung kanilang unit, so hindi na natin sila i-convert into meters. We only convert them into meter if they have different unit, okay? So just like this example, since they are different in unit, so i-convert muna natin sila into meters. But before that, since it is in diameter, so kunin muna natin ang kanyang radius by simply dividing our diameter by 2. So divide natin si 100 by 2, that is equal to 50. So we have 50 millimeter and 50 divided by 2, we have 25, and that is equal to 25 millimeters. So that these are the radius of the pipe. So 50 millimeter and 25 millimeter. After we divide it by 2 to solve for the radius, okay, before we can solve for the equation of continuity, first we need to convert millimeter into meters. So 50 millimeter times 1 meter divided by 100 millimeters. So cancel yung millimeter. So maiwan is 0.0050 meters. Same with 25 millimeter. So convert into meter, that is 0.0025 meters. So after we convert them, so since radius pa lang sila, hindi pa natin siya magamit in the equation of continuity because we need the area. So we solve for the area. by using the area of a circle, which is pi r square, times the converted radius, 0.05 meter. So that is equal to 0.000025 pi square meters. And for the area 2, which is the change in diameter, that is equal to 0.00000625 pi square meters. Okay? So after we solve for the area, so na-convert na natin sila, na-divide na natin ang diameter, and solve na rin natin yung kanyang area. So we can now substitute this in our equation of continuity. Okay? So divide both sides by 0.000625 pi. So cancel yung kanyang pi as well as square meters. Okay, so multiply 0.0025 times 10 divided by 0.00625, and that is equal to 40 meters per hour. So after that, since we only have one significant figure and 40 has one significant figure, so the volume or the velocity, okay, the velocity is now equal to 40 meters per hour. Okay, so yan yung velocity ng ating water as the diameter of the pipe is reduced into 50 millimeters. Okay, so last example. A typical faucet has a diameter of 1.7 centimeters and water travels at approximately 0.8 meter per second through it. So, how many cubic meters of water is consumed if the faucet is left for 10 minutes? So, yung hinahanap natin ngayon is ang cubic meter or yung volume. So, if ma-remember nyo pa kanina, based on the derived equations that I have presented kanina, so meron dun how to solve for the volume using the area, the velocity, and the time of the time given for the time interval. So in this case, so we have the velocity, which is 0.8 meters per second. We also have the time, which is 10 minutes, and the diameter, which is 1.7 centimeters. Okay? So since they have different, okay, since different yung kanilang mga unit, the diameter and the velocity has different unit, and also the velocity and the time has different unit. So convert muna natin sila, okay, so that magkakapareho ang kanilang unit. Before that, okay, so before that, since in our area, we need a radius, so divide natin yung kanyang diameter by 2, and that is equal to 0.85. So that is the radius of our pipe or of our faucet. So after we solve for, we divide the diameter by 2 to solve for our radius, convert natin yung ating radius into meters. And also, our time into seconds. So since hindi pwede cancel yung minute and yung second, so convert muna natin si minute into seconds. Okay, so 0.85 centimeter convert into meter, that is 0.0085 meter. And 10 minutes convert into seconds. So cancel yung minute. So 10 times 60, that is 600 seconds. The next is to solve for the area. So since ang kailangan natin ay kanyang area. So pi r square times the radius is 0.00072225 pi square meter. Then lagay natin siya sa ating equation, which is volume is equal to area times velocity times the change in time. So multiply, so cancel yung seconds. We can now cancel the time since it is same yung kanilang unit. So multiply, that is equal to 0.100895 cubic meter. Then, since the least number of significant figure is only 1, so round natin siya into one significant figure, and that is equal to 0.1 cubic meter. Okay? And that is the volume of the water. Okay? So Bernoulli's equation, it is almost the same, or it is um, somehow has it's almost it has the same, so it is the same with the equation of continuity. So in equation of continuity, since in equation of continuity only the area and the velocity is included, so in Bernoulli's equation, aside from the area and velocity, so pressure is also included in the Bernoulli's equation. Okay, in the Bernoulli's equation, aside from area and velocity, pressure is also included. And the same with the concepts of equation of continuity, if there is a decrease in area, so yung kanyang velocity is mag-increase. Okay? But if there is an increase in area, so yung kanyang velocity naman ang mag-decrease. There is also a change in pressure if there is a change in velocity. So if mag-increase yung kanyang velocity, if mag-increase yung kanyang velocity, yung kanyang pressure is mag-decrease. So if mag-increase yung kanyang pressure, yung kanyang velocity is if mag-increase yung kanyang velocity, mag-decrease yung kanyang pressure. So kung tataas yung velocity, bababa yung kanyang pressure. Same with if yung velocity is bababa, yung pressure naman is tataas. Okay? So pressure and velocity is inversely related din. So since if mag-increase or magtaas yung kanyang velocity, bababa yung pressure. And if bababa yung kanyang velocity, tataas naman yung kanyang pressure. So they are inversely related. And the equation in Bernoulli's equation, so we have the pressure sub 1 plus 1/2 of the density times the square of velocity sub 1 is equal to the pressure sub 2 plus 1/2 of the density times the square of the velocity sub 2. So this is the Bernoulli's equation.